In this section we're going to be discussing slope and linear equations. Our goal here is to teach you a fast way to not have to memorize as much as you do understand, and then the formulas that you're going to learn will be much easier to remember because in fact they come from one thing. And if you can take that one thing and manipulate it, then you can remember all the other equations without having to memorize. So let's take a look at what we know about a line. Here we're going to come up with the equation for this line, and the first thing that you want to realize about a line is that it has a slope. It has a specific way that it's either going up at a certain angle or up at a certain rate or whatever you want to call it, and that up or down at a certain rate is called the slope, and it's usually given by the letter m. And what we want to remember about slope is that it is written as rise over run. You have probably heard that before, and rise over run is a fraction, so all slopes are fractions. And what we do to find the slope is try and find two known points on the graph. So let's kind of go to the graph and indicate, well, here's one at 0, 0, and here's another one at the point 4, 3. And we're going to find the slope of this line so that we can come up with the equation of this line. And we're going to do it with the points and also kind of a general formula for coming up with the slope. Well, let's remember that when we talked about points on the line before, we said, well, let's call this our second x and our second y. And let's call this our first x, x sub 1, and our first y, y sub 1. Then what I want you to do is kind of imagine that there's a right triangle created. And you could do this way also. It doesn't matter, it's actually a rectangle between it. But it'll show us what our rise and our run is. So we say in order to get from any one point on the graph to another point on the graph, we would have to rise a certain amount. And then we would run to go to the left or right. Well, let's kind of define that. If we said how long is this line right here? We discussed before that the slope was y2 minus y1. This was the difference of the vertical numbers, or vertical points on the graph. So we had y2 of 3 minus a y1 of 0 gives us a rise of 3, which is in fact true. Then we said the run was the difference between the x's, x2 minus x1. Now if your x2 is 4 and your x1 is 0, 4 minus 0 is 4. So we know that we have a slope of the rise number, which is 3, over the run number, which is 4, on this particular line. And we know that the general way we came up with that 3 was y2 minus y1 over x2 minus x1. That's how we came up with those numbers. So there is the equation for slope. If you know this equation, you now know every form for a linear equation, because they're all derived from the same formula for slope. All you need to come up with the equation for a line is one point and a slope. And if you don't have the slope already given to you, then you can do the same thing with 2 points. But to get the equation, we need 1 point and a slope. Alright, so let's kind of find out how we get with the general form going from the slope equation to the linear equations. Let's come up with the equation for our line. So once we have the formula for finding slope, watch what happens when I take the bottom, or the denominator, which is x2 minus x1, and I multiply it to the other side. Then I would get y minus y1 equals m times x minus x1. And notice that I didn't call it x2 and y2, because in order to get the equation we only need 1 point. So we're going to use x1 and y1 as the 1 point. The other 2 variables, the x and y, will be the variables in our equation. This form right here is called the point-slope form of a line. And how you remember that is because we have 1 point, x1 and y1, and 1 slope. So point, slope. So let's plug in our values. We're going to use the point 0, 0 because, boy, zeros are really easy to plug in. So we're going to say y minus our y1, which is 0, equals our m, which is 3 over 4, times x minus our x1. This gives us y equals 3 over 4x. So by simplifying our point-slope equation, we ended up with a y equals 3 over 4x, an equation solved for y. When you solve the point-slope equation for y, you get what's called the slope-intercept form. Let's clean that up a little bit. Slope-intercept form. I'll learn to spell sooner or later here. So now we have slope-intercept form, and we say, well, where is the intercept? Because we know this is the slope. Well, the intercept is what's sitting right out here, and that number in this case is 0. So here you would have your slope, and here is your intercept. Whatever that number is your y-intercept. And we're going to discuss that now. So just taking this one equation for slope, if we multiply the denominator to the other side with the m, we get the point-slope equation of the line. And then once we solve that equation for y, we get slope-intercept. So now you see that if you know one equation, just the formula for slope, you could remember both of the other ones just by multiplying out the denominator or solving for y. It leaves you with only one thing to memorize. Okay, so now let's discuss what all this intercept and stuff means. So let's say we have slope-intercept form, and we need to prove that what we've done is correct. First of all, y-intercept is where the graph touches the y-axis, and we're saying that that's at 0. Well, in fact, the y-axis is being touched right there at 0, and I'll do that in green. It's right there at 0. So that's our y-intercept. From there, we said we only need a slope, because that's one point on the line. Now we need our slope, which says rise of 3 and a run of 4. So from that point on the graph, the y-intercept, we would rise 3 and run 4 to get any other point on the line. We could stay there at that point, rise 3 and run 4 again, and we would get yet another point on the line. And you could do this until you had infinite amount of points on the line. Well, let's do some examples of starting with points and slopes and see if we can use that to kind of perfect our technique for coming up with everything we need. And what I like to do is a holistic approach. I like to find all three things that we need and find both types of equations, and then we can graph it. We'll do it all at one time so that you can kind of see how the thinking goes. Let's say we're only given 2 points, and we have 2 points of -1, -2, and another point which is going to be 3, 1. And we need to come up with the equation in both point-slope and slope-intercept form, and we're going to graph it. Well, recall that what we need is to graph is 1 point and a slope. That's what we need to graph it. Well, we don't even have a slope yet. So obviously the first thing we need is the slope. And we know that the one thing we need to learn is the slope is the y2 minus y1 over x2 minus x1. So we plug our values in. We're going to call this point x1 and y1, and this point x2 and y2. Now, does it matter which one you call x1 and y1 and what have you? No, it doesn't. Your answer will come out right both ways. So we just have to plug it in the right direction. y2 minus y1, which would be -2, and always use parentheses when you're playing with negatives so you don't mess up your signs. Then you have x2 minus x1. A negative times a negative is a positive, so you have 1 plus 2 on top, which is 3. And a negative times a negative is again positive, so 3 plus 1 is 4. So we have a slope of 3/4. And that's our m. Now that we have a slope, we need 1 point and a slope to make the equation. Well, recall that we take the denominator of our slope equation and we just multiply it over to the left side and we get our equations for our line. So now we have y minus y1 equals m times x minus x1. and we just plug in our values. So here we have y minus y1, which is negative 2, equals our m times x minus x1, which is negative 1. Again, use parentheses to avoid simple mistakes. A negative times a negative is positive, so we have y plus 2 equals 3/4 x, and this is negative times a negative again, so plus 1. This is the point slope equation for our line. To graph it, it's easier to put it into a slope-intercept form, which is just meaning solve for y. So we're going to take our 3/4 and distribute it to both the x and the 1. So on the right side we would have 3/4 times x plus 3/4 times 1. And this would equal y plus 2. From here we just need to subtract 2 from both sides. This would give us y is equal to 3/4x, and now we just need to remember how to subtract fractions. So in order to subtract fractions, when one number is a fraction, make them both a fraction, and since the denominator is 4, we just need a 4 over here, so we're going to make 4/4, which is 1, and we're going to multiply that out. So what we really end up with here is 3/4 minus 2 times 4 is 8/4, and that gives us negative 5/4. So that adds to our equation there. Now we have the slope-intercept form of our line, remembering that the second value is your y-intercept, and then we have a slope. So we go to our graph and we say, well, negative 5/4 is, well, 4 goes into 5, that's the same as negative 1 and 1/4. So we're going to go down negative 1 and 1/4 would be somewhere around here, and that would be a known point on the graph. And from there we're going to go up 3 and over 4. So up 1, up 2, up 3, and then over 4. 1, 2, 3, 4. And there's a known point on the graph, and then we just connect the dots. And that's it. So we now have started with 2 points, given our slope, then take that equation and make the equation for our point slope form, plug in our points, which gives us our point slope equation, and then solve for y, giving us our slope-intercept equation, which is much easier to graph. Now there are two special circumstances about slope that are necessary to understand. That when a line has a slope at all, as a number, as an integer, let's say, or a fraction, it's going to be a line that is slanted in some way. So positive slopes move up to the right and negative slopes are going to be down. And now we need to decide, well, what happens when the line is flat? So what happens when this yellow line is our line? And what would the slope of that line be? Well, we say, okay, pick 2 points on the line, just like we did before, and find the slope. Remembering that slope is rise over run. So if I was going from this point to this point, would I rise anything? And the answer is no. So I have no rise, but I would run 3. I just picked known points, and that means my slope is 0. So horizontal lines have a 0 slope. So think about what that would do to your equation, and notice that on this line, that's the line, the x-axis, so that would be where the equation is y equals 0. And if I had a horizontal line above that, let's say, you would say, okay, well, that would make y is 3, and no matter where I am on that line, y is 3. So the equation of that line is y is 3. In addition to that, now let's talk about a vertical line. So let's kind of delete some mess here. And doing so, we say, okay, let's look at the easiest vertical line, which is the y-axis. And we need to find the slope of a vertical line. And once again, just use what you know. Plug any 2 known points on that graph, on that line, and now identify them. So we say, okay, what's the slope? How would I get from this point A to point B? I'm remembering that my slope is rise over run. Well, in this case, I'm rising 5. So my rise is 5, and I'm not running at all. So my run is 0. When you divide by 0, it's called undefined, because we cannot divide by 0. So vertical lines have undefined slopes. Now let's think about the equation of a vertical line. Notice that no matter where we are on that line, x is 0, and the equation there would be x equals 0. If I moved that line back, let's say to here, then we notice that x is negative 4, so the equation of this line would be x equals negative 4. So if you sense the pattern there, horizontal lines have equations of y equals wherever they are at. In this case, if this is some a, then we would just call it y equals a. And that would be a horizontal line. Vertical lines have x equals equations, and that's how you define them. Now we're going to deal with two other properties of lines, special things that happen with lines, such as being parallel and perpendicular, and see how to tell the difference and how to identify those. Let's deal with parallel lines first. And the way to remember parallel, if you forget, is the two L's in parallel are going in the same direction, so that tells you they're parallel. Well, that tells you a lot about the line also. So let's kind of draw a parallel line to this, and you would get a line that looks something like this. And you say, whoa, those are going in the same direction, kind of like train tracks. And what would make them parallel? Well, to get those things, we need to look at what we know about slope. If we have one known point on our graph and another known point, we'd say, what's the slope of this line? We went up 3 and over 4. So this is 3/4 as a slope. Well, now look at our parallel line and pick 2 points and say, how did we get from here to here? We also went up 3 and over 4. So both slopes were the same, and that's how you tell parallel lines. If you're given two equations, in example 3 over 4x and y equals 3 over 4x minus 2, these are the equations for these lines. And you'd say, well, we know they're parallel because their slopes are the same. So if you look at the slopes of two equations and the slopes are the same, then the two lines are parallel. These two lines are perpendicular, which means that they're meeting at a 90-degree angle. So let's discuss how we can identify, as a general rule, how to identify perpendicular lines. And what we want to do is, we've already known that our first line has a slope of 3/4. Well, let's find out something about the slope of our second line. And so we'll pick two easy points on that line and see how do we get from one to the other. Starting at our first point, if we rise 1, 2, 3, 4, so we rise 4, and then we run left 1, 2, 3. Well, left on the x-axis is negative, so that would be negative 3. And we have the slope of our perpendicular line. What do you notice about the slope of the perpendicular line compared to the slope of the other line? Is that it looks like the first slope, if we flip it over and change the sign, we get the slope of the line perpendicular to it. And that is exactly what you do to find perpendicular lines, is you identify their slope and you flip it over and change the sign. It's what's called the negative reciprocal. So let's say that we have y equals 3 over 4x, which is right here, and we say what would be any perpendicular line to that. Well, then we pick any point. We can pick the point 0, 0. And we say now we know a slope. The slope would be the negative reciprocal, so negative 4 over 3x. We could now give the equation of a perpendicular line. Just pick any point. And so we say y minus y1 equals m times x minus x1. Well, obviously x minus nothing is x, so you just have negative 4/3 x. And y minus nothing is just y. So here is the equation of a line perpendicular to our given line. Notice that there are infinite perpendicular lines. You could create just infinite amounts of lines that all have the same slope of negative 4 over 3, and they would all be perpendicular to 3/4 x. A car is bought for $10,000. the buyer is told that the car will have no value in 6 years. Create a linear equation that can estimate the car's value in 4 years. Well, here's just an example of relating two things to make a linear equation. So it's just a really neat example of how you can use lines to simulate something you need in real life, because everyone scratches their head and wonders where we're going to use linear equations in real life. Well, here we've got somebody buying apparently a used car. I don't know any new cars that cost only $10,000, but we'll see. And so let's assume it's just a car that's bought for $10,000. Well, that means brand new. So we're relating age and years with, or time, with money. So we're going to identify 2 points, because to make a line we have to have 2 points to get the slope, and then we use 1 point and the slope to make the equation. So we have a relationship between its age. Well, when you first buy it, it doesn't have any years on it, so the age is nothing, but the money is $10,000. And then we have another point which they gave you, that after 6 years the value would be 0. It's not going to have any value. So the depreciation on this is quite fast on this car. Let's go ahead and kind of try and sketch out a graph of just of these 2 points by itself to give us an idea of our line. Now obviously we don't have enough space to graph 10,000 dots, but we can call each one of these 2,000. So 2,000, 4,000, 6,000, 8,000, 10,000. So if ours is 10, we're going to put our dot right there and we'll call it 10,000. And that's the point 0, 10,000. Then we can go to our graph and say after 6 years, we can let x be, all the x's be ones in years. So this would be 6 years, and over here would be money. Again, you're relating two things. And so at the point when 6 years goes, then its value will be nothing. So you can imagine that your line will look something like this, and we want to use this line to guess at what the value is after 4 years. So let's kind of hope that it's somewhere in that region if we've done something right. And that, let's see, if each one of these is 2, so between 2,000 and 4,000 should be our answer. And let's see how good our line is at guessing that. So that being the case, let's kind of identify our points, and we say that this point will be our second x and our second y, and our first x and our first y. Again, does it matter what order? And the answer is no. So we're going to find our slope, which is y2 minus y1 over x2 minus x1. y2 is 10,000 minus y1, which is nothing, over x2, which is 0, minus x1, which is 6. So we end up with a slope of 10,000 over negative 6, or negative 10,000 over 6. Now notice that 2 can go into those, so we can reduce this to negative 5,000 over 3, just for a little bit less of such a daunting number. Now we have a slope. We just need 1 point and the slope to come up with the equation. So now we take our formula, move the x2 over, we get y minus y1 equals m times x minus x1. Now we plug in our points. So we say y minus y1, which is 0, equals m. So we have our negative 5,000 over 3 times x minus x1, which is 6. Well, y minus nothing is just y. And then we have over here negative 5,000 times over 3 times x. And now distribute to the negative 6. Well, a negative times a negative is positive. And we'd have the negative 5,000 times negative 6 be positive 30,000 over 3, which is 10,000. Now all we need to do is say we wanted to guess at what happens when t is 4 years, or when x is 4 years. So we plug in a 4 where the x is. Over 3 times 4 plus 10,000. When you punch that into your calculator, you get approximately $3,333.33. Now, we said on our graph that this was 2,000 and this was 4,000, and the point we guessed at on our line was roughly between 2 and 4, which that's a pretty reasonable answer. So you can use this estimate to say your car is going to be worth a little more than $3,000 after 4 years.